angular speed about a point P on a circle. What I'm asking, so what information I have? I have like this, V equal to R omega naught. V is not given, omega naught is given. This angular velocity about O, we know it. Then what is the angular velocity of the same particle about a point P on a circumference? Actually, particle is moving in circular path. Now, what is the angular velocity about O, omega naught will write. That is a given for us. So the tangential speed is this much. Now I'm asking what is the angular velocity about P? Will it be same or different? It is to be. So let's do one thing. Let's calculate. Nothing is there. So this is the theta. No. So how you define theta? How you define theta? This angle made by the, how you define angular velocity omega naught? I'm discussing here. Omega naught, you write it d theta by dt, no? What is the angular velocity definition? Rate of change of angular displacement. So when the particle starts moving in circular path, so what will happen to its theta? Theta is going to vary. So rate of change of angular displacement is what? Angular speed omega naught. Okay, similarly, I'm asking angular velocity about P. So when I ask angular velocity about P means, so the omega P, I'll show it here. Omega P. So let this angle, let it be phi. We don't know that. So what is omega P? Omega P, according to the definition, the omega P should be d phi by dt, no? So to calculate this, we should calculate to get the angular velocity of particle about P. This is a particle. Huh? P is not particle. I think some you'll get confused. Huh? Oh, okay, fine, no problem. We'll proceed here. So can we calculate this d phi by dt? So we'll take help of this one. According to the circle, so watch with this angle also. Should be phi, no? Isosceles triangle. Then how theta and phi are related, as we know that from circle. Theta should be equal to 2 phi. Will I agree? From the circle concept, exterior angle should be equal to sum of interior angles. I'll differentiate this. D theta by dt equal to d theta by dt is what? Omega naught. D phi by dt is what? Omega p. So what is omega p? Omega naught by 2. So the particle which is revolving about O, it will have angular velocity omega naught. About P, about any point on about point P, it will have how much it is omega P. Means what actually we are not understanding anything. See, like it's like you can describe that particle moving in circular path either with respect to O or with respect to P. If with respect to P, angular velocity is omega P. With respect to O, it will be omega naught. Able to understand? No. So now, what is the rule? Like the year till now in the beginning, what when we made the O as a reference, it is very easy for mathematically. Means, sir, I'll stand at point P. Will you see this moving in circular path? So at with respect to O, it moves in circular path. With respect to P, it's not circular path. At least I think everyone is very clear with the mathematics, basic geometry. So if you stand here, so your particle will move away from you, no, and here it will be at maximum distance. So it's not a circular path, no. So it's not a circular path. Can you define angular velocity? There's no rule that only for circular path you have to define angular velocity. Already we have seen two particles. They're moving in a plane. We brought the idea of circular path here. Fine. There's a simplest thing. Or you do one thing. I'll find out V, then I'll find out the component of V perpendicular to this R. Sir, I'm very good in mathematics. Okay, you try, no problem. Then I'll resolve component of, I'll find out small r. Then I'll find out component of velocity perpendicular to line joining the particle and point P. Then the basic definition. What is angular velocity? V perpendicular by R. You do that, you'll get the same answer. Is it okay? You can try with mathematics, no problem. Because what is the basic definition? Omega equal to V by R. So how V and R should be perpendicular. So this V is not perpendicular to R. I'll put some conditions which will really help you here. V is not otherwise, if it is perpendicular, I would have wrote it. Whereas V is perpendicular to R bar. At the same time, V bar is perpendicular to R bar. Are you getting no? Now, means sir, with respect to any point, I can define the circular motion as so slowly you move out, sir. Why only on point? So let's do one thing. The last one I'll wind up because again tomorrow you have to prepare for exam. No, let me take 3 points here. A, B like this. This is say like a X. This is R. There's a radius of circular path and particle is moving with a constant speed V. No. When particle arrives here, what is the angular velocity about O, about A, about B? Particle moves with constant speed V in circular path of radius R. No. What is angular velocity about O? Find omega O, omega A and omega B. I think it's quite very clear, no? What is omega O? V by R clockwise. Anybody omega B? Should be V by 2R omega C V by 2R plus X. It is now getting the idea. If you stand at O, you see one angular velocity. If you stand at A, you see one angular velocity. If you stand at B, you see one angular velocity.
Sir, for a rolling sphere, when we take the instantaneous axis of rotation,
in rotational mechanics, I'll explain. No, don't trouble everyone.
Sir, there will take the same omega, right? Sir, we won't take omega by 2.
No, sir, nothing. The rolling motion is totally different. When it comes, I'll explain. I do remember your doubt. So still that instant center idea is still not clear for you. That's why you're asking same omega. The frame of reference will be different. With what angular velocity the particles are rotating about, or with the same angular velocity, it will rotate about instantaneous center. The frame of reference is different, but still we see. How do you can say same omega? When I measure angular momentum and kinetic energy, I do get same. So therefore, I'll conclude same.
Sir, for omega C, could you once show it mathematically, sir?
It's like a, what is the perpendicular distance? 2R plus X. And what is a V? V is directed perpendicular to radius vector. Finish or no? The definition.
Yes, sir. Could you once show the perpendicular distance?
The X plus 2R. What is the distance? This will be 2R and this is X. So I'll indicate that omega naught like this here. This will be omega naught. Just perpendicular distance. From the particle to the point B, you measure the perpendicular distance.
I was taking another particle, sir. Sorry, sir. Got
okay,
it.
Fine. Tomorrow, if time permits, I'll discuss few more so that you'll get a clarity. Circular motion, what happen, you feel something, it's a thing. So again, what happened is just if you know some simple idea is enough. I made things very complicated. Tomorrow I'll discuss few more problems. You feel like, okay, sir, now okay, sir, we can manage. If not a circular, if particle moving any direction also, it'll be circular motion, we can manage. Like that, we can conclude tomorrow.
Sir, with respect to B, it will be in circular motion, right, sir, here?
No, with respect to, see, if you stand at O, you feel it's moving in circular path. If you stand at B, how do it will be at one point, it'll be at a distance how much? 2r plus x. When it is passing at A, at that instant, I'm telling you, no.
Okay.
Are you getting? So when particle again comes here, you see that one. When it is here. So what you should do, you have velocity v like this. And this is the thing. So component of velocity calculus, then angular velocity. So definitely the angular velocity with respect to B, will it be constant? No, at that position when the particle is at point, I'll give that one. Particle moves with constant speed in circular path of radius. Find omega naught, omega, omega b.